Section 1.4 is all about angles. Before we start, let's first define what an angle is. An angle is a geometric figure that consists of two different rays with the same endpoint. So if you look at the diagram over here, we have ray AC, it's just missing the arrow at the top, and ray AB, which is also missing the arrow, and they're sharing that same endpoint A. When we're talking about the sides of an angle, we're just referring to the two rays that made up the angle. If we're referring to the vertex of the angle, we're talking about that common endpoint that they were sharing. Next, let's talk about how to name an angle. The symbol for an angle looks like an angle itself. So if I'm going to name this angle over here on the right, the one way to do it is angle CAB. Notice I put A in the middle because the vertex is A. Another way is just to flip the letters around, angle BAC. One last way to name this angle is by the vertex itself. Since there's only one angle there that is sharing the vertex A, I can name it simply just angle A, since, again, the vertex is A. Let's go ahead and show what the sides of the angle is. So we would say the sides are the rays AC and ray AB. And once again, just to reiterate, we always want to put the vertex in the middle when we're naming an angle with three letters. Next, let's talk about the types of angles. These should be familiar to you. First, we have acute angles. Acute angles are greater than 0 but less than 90. Right angles are always exactly equal to 90 degrees. Notice this symbol in here, which is a little tiny box, to show on a diagram that that angle is equal to 90 degrees, that it's a right angle. Next, we have obtuse angles, which have to be greater than 90 but then less than 80 at the same time. And finally, we have straight angles, which is basically like the angle's been opened all the way up into a straight line. So it's exactly equal to 180 degrees, since a straight line is 180 degrees. Let's look at our first example. Name the three angles in the diagram. As it was stated before, you can name an angle by its vertex as long as there's only one angle sharing that vertex. But in this case, I actually have three angles all sharing the vertex of N. I have this angle right here, this angle right here, and then also the big angle from M to P. So I cannot name this angle just simply angle N, because which one are you referring to? There's three there that have a vertex of N. So the three angles in here can be named angle MNO. That's that first angle right here. The next one would be angle ONP. It's the next smaller angle right here. And then let's go ahead and name the big angle MNP. Next is the protractor postulate. If you guys remember back to section 1.2, we talked about a ruler postulate, which basically just allows somebody to give length to a segment. This protractor postulate does the same thing and allows you to measure angles with a protractor. If you want to write the measure of an angle, just like it says here where it's highlighted measure of angle AOB, the shorthand way to write that is with the little tiny m, angle AOB. Zooming in here, let's look at what a protractor does to begin with. So when I look at this blue angle, it is greater than 90 degrees. It's an obtuse angle. So when I'm reading it, the first thing I want to make sure of is that the vertex is right here at the center, and one of the rays of the angle is lined up with the bottom line. So then when I'm measuring the other side, I'm going to look out at where it's hitting. Since again this is greater than 90 degrees, you can see here that we have it's at 40 and at 140. Since we know it's obtuse, we would go with 140. If this had been an acute angle, I would know to use the smaller number. Again, thinking back to previous lessons, we had the segment addition postulate, which allowed us to take two smaller segments that make up a big segment and say that those two segments added together equals that big segment. The same goes for angles. We can take two smaller angles like this angle here and this angle here and add them together, and that would give you the measure of the big angle. So if you see here, we read it as the measure of angle ABZ, that's this one, plus the measure of angle ZBC, that's this one. If I add those two together, that would equal the big angle, angle ABC. Just like we have congruent segments, we also have congruent angles. So just like when we had for the segments, if I'm referring to the measures themselves, I'm going to use an equal sign. And in this case, since we're talking about the measure of an angle, we're using that little small m in front of it. If we're talking about the angles just being congruent to each other and not actually their measures, we're not going to use the little m's and we'll use the congruent sign. To mark it on a diagram, you use these little crescents to mark that those two angles are congruent. So congruent angles A and B. Let's look at example 2. It says, use the diagram to find the measure of each angle and classify the angle. So let's start with angle DEC, which is part A. So DEC, you can see here, is exactly hitting at 90 degrees. That would be a right angle. Next, for part B, we have angle DEA. So let's first identify where that's at on the protractor. So DEA, that's straight across the protractor, so it would be 180 degrees, which would be defined as a straight angle. Moving on to part C, we have angle CEB. So again, let's look at what that is on the protractor. CEB. So this one's a little bit tricky because everything's not lined up along the bottom of the protractor that we have. But just with some simple arithmetic, we can figure it out. This ray is hitting at 90 degrees. This ray is hitting at 70 degrees. So the number of degrees between 90 and 70 would be 20. If I have an angle that is equal to 20 degrees, that would be classified as an acute angle. And finally, let's look at part D, which is angle DEB. So you can see here it's greater than 90 degrees, so we're going to have an obtuse angle. So from DEC we have 90 degrees, which we just saw from here to here is another 20. So just taking 90 plus 20, we can go with 110 degrees. And again, that would give me an obtuse angle. Example number 3 deals with that angle addition postulate. If you see here, we are given two smaller angles, angle XYW, which is 3x plus 6, and angle ZYW, which is 2x minus 9. In the instructions, it says if the measure of angle XYZ is 72 degrees, so the whole angle is 72 degrees. They want us to then find the measures of angle XYW and the measures of angle ZYW. So again, we know that if I take the smaller angles, add them together, they would give us that total of 72 degrees. So let's set up our equation. Let's first take 3x plus 6, add it to the 2x minus 9. Again, I'm adding because they gave us the total angle degree, which was 72 degrees. Just by doing some simple algebra, let's first combine like terms. So that 3x plus 2x is 5x. Positive 6 and negative 9 would be negative 3. Add 3 to both sides. 5x equals 75. Divide both sides by 5, and we get x equals 15. Our problem asks to find the measures of angle XYW and the measure of angle ZYW. So simply stopping here is not enough. We want to take our x equals 15 and plug them back into our expressions for the two smaller angles. So the measure of angle XYW would be found by taking 3 times 15 plus 6. 3 times 15 is 45, plus 6 is 51. So we have 51 degrees for the measure of XYW, and for the measure of angle ZYW, we're going to substitute the 15 in for that expression. 2 times 15 minus 9. 2 times 15 is 30. 30 minus 9 is 21 degrees. So here are our two final answers. Example number 4. The figure shows examples formed by the legs of an ironing board. Identify the congruent angles. So if you see here, we have those crescents marking that this angle, G, is congruent to angle J. That's a J down there, kind of got cut off. And then we see 2 of the little crescents marked on angle H and on angle K. So since I'm just talking about the angles themselves and not their measures, I can just say angle G is congruent to angle J. I can refer to these as just angle G and angle J and angle H and angle K because when you're looking at the diagram, there's only one angle here that shares that vertex of G, and the same goes for H, J, and K. So it makes our work a little bit easier since we can just refer to them by their vertices instead of naming it with 3 letters. So moving on, we'll have also angle H congruent to angle K. And then our question at the bottom here says, if the measure of angle HGI is 40 degrees, so HGI, so they're saying if this is 40 degrees, what would be the measure of GJK? So GJK is this angle right here. Remembering that angle G and angle J are the same, the measure of angle GJK would also be 40 degrees. Just like with segments, we can also have angles that are bisected. Remember when we heard the words midpoint, we thought, well, that just cuts the segment into 2 congruent segments? Now if we hear that an angle is being bisected, or we have an angle bisector, we know that the angle is being bisected into 2 congruent parts. So in this diagram, it says that ray MN bisects angle PMQ. So that tells me that these 2 smaller angles are congruent. So notice how as I'm reading through the problem, I'm marking in my diagram the stuff that I'm given, the information that I'm given. Next, we know that the measure of angle PMQ, so the whole angle is 122 degrees. And they want us to find the measure of PMN. PMN is this bottom angle right here. So if we know that the total angle is 122 degrees and the 2 smaller angles are congruent, then all I have to do to find the measure of angle PMN, like the problem asks, is to take that total of 122 degrees and divide it by 2, since I know, again, that the 2 angles are congruent. So our answer would be 61 degrees. If this angle is 61 degrees, then also this angle is 61 degrees. I realize the problem didn't ask you that, but just for clarity's sake, both angles would equal 61 degrees, and the big angle, again, is 122 degrees. Make sure you jot down any questions that you have so we can cover them in class, and we'll see you then.